So students, in the last video we have completed problems in Cauchy's integral formula, Cauchy's theorem, etc. Now we will move to next topic. You see, the next topic is Taylor's theorem or Taylor series. Okay. The statement is let f of z be analytic everywhere inside a circle C with center at z0 and radius r. Then at each point z inside C we have, this is a formula for Taylor series, f of z equal to f of z0 plus f dash of z0 by 1 factorial into z minus z0 plus f double dash of z0 by 2 factorial into z minus z0 whole square, etc. So the nth term will be f n of z0 by n factorial z minus z0 whole power n plus etc. up to infinity. And this whole series can be written like this. If you write summation n equal to 0 to infinity, it is enough if you write nth term. If you want, you can check. If you put n equal to 0, 0 factorial is 1. This z minus z0 whole power 0 is 1. F of z0. So no need to write 0 means what? 0 the derivative. So no need to write 0. So if you, it is enough if you write f of z0. And if you put the next number n equal to 1, n equal to 1 means the first derivative, f dash of z0 by 1 factorial z minus z0 whole power 1. And if you put n equal to 2, 2 means second derivative by 2 factorial z minus z0 whole square, etc. So this whole series can be written as in summation form, summation n equal to 0 to infinity fn of z0 by n factorial into z minus z0 whole power n. Okay. So the statement is not important, they won't ask in the examination. Using this statement you have to solve the problems. So problems is very important in the Taylor series. Now note, when z0 equal to 0, the center is z0, when z0 equal to 0, Taylor series becomes Maclaurin series, isn't it, which you have studied in first semester also. Taylor series about the origin. Taylor series about the origin is called Maclaurin series. The same thing here, when z0 equal to 0, Taylor series becomes Maclaurin series, which is, so in place of z0 you put 0. Here also 0, so z minus 0 is what is z power n. So this is a formula for Maclaurin series. And in this topic we are going to use these formulas. So these are all standard results. Sin z formula, z minus z cube by 3 factorial plus z power 5 by 5 factorial, etc. Similarly, cos z is 1 minus z square by 2 factorial plus z power 4 by 4 factorial, etc. For sin z you will get odd numbers 1, 3, 5, etc. For cos, the first term is 1, other things are even powers 2, 4, 6, etc. And sign changes alternatively in both the formulas. This you know that e power z series formula, e power minus z, the sign changes alternatively. Okay. So already I given 4 results. The next result, sin hz. You know that hyperbolic function sin hz formula is e power z minus z by 2. So if you subtract the third and fourth formula and divide by 2, you will get this series. Similarly, cos hz, the formula is e power z plus e power minus z by 2. If you add third and fourth formula, you will get this series. So these are the important results. Next come to nth derivative. So these are the formulas in nth derivative. The first one, if y equal to e power ax, then, so just I will show this one first one I will prove this. If y equal to e power ax, then what is what is first derivative? First derivative is denoted as y1. Okay, that is dy by dx. What is first derivative? E power ax into a, which is what? A e power ax. What is second derivative? Second derivative is what? D square y by dx square, which is denoted as y2. So you will get e power ax into a. Already a is there, a is a square. A into a is a square. Similarly, third derivative will be e power ax into a. Already a square is there, a square into a is a cube. So it goes on. So what is nth derivative? Using this a power n, e power ax. Okay, that's why I written here. Similarly, the nth derivative formulas. If y equal to 1 by x, y equal to 1 by ax plus b, then nth derivative formula is this one. If y equal to 1 by ax plus b whole square, then nth derivative formula. If y equal to log of ax plus b, then nth derivative formula. Similarly, for sine and cos, the nth derivative formula is given. So you have to remember all these formulas for solving the problems. So next is a binomial series. This formula also you should know while solving the problems. For solving the problems, binomial series. If mod x less than 1, mod x means what? Mod x less than 1 means what? You have to write like this. X lies between minus 1 to 1. Okay. Mod x less than 1 means x lies between minus 1 to 1. So we want the proof for this. Mod x less than 1. Mod x means what? Plus or minus x. So x less than 1 or minus x less than 1. Okay. Now multiply by minus on both sides. If you multiply minus on both sides, x inequality will becomes greater than. So x greater than minus 1. Again he interchanges. I'll write minus 1 here and x here. Again the inequality changes into less than. Okay. Now combine these two. Minus 1 less than x. That x is less than 1. So mod x less than 1 means you can write like this. X lies between minus 1 to 1. Okay. So binomial series always lies between minus 1 to 1. So then the formula, you know this formula, 1 plus x square plus x cube, etc. So the nth term will be x power n. And the whole series can be written as in terms of summation. N equal to 0 to infinity x power n. If you put n equal to 0, 1. If you put n equal to 1, x, second term. If you put n equal to 2, x square. If you put n equal to 3, x cube, etc. The whole series can be written in summation form like this. Similarly, 1 plus x whole power minus 1 is, here the formula sign changes alternatively. Since sign changes alternatively, the nth term will be minus 1 whole power n into x power n. And the whole series can be written as summation n equal to 0 to infinity, then you write nth term. And the next formula, 1 minus x whole power minus 2. The formula is 1 plus 2x plus 3x square plus 4x cube, etc. So the nth term will be, now see here the constant goes on increasing. Second term is x, third term is 3, the next term is 4, so the nth term will be n plus 1 into x power n. So see here x power 1, 1 means we have 2, 2 means 3, 3 means 4, so n means you should have n plus 1. And the whole series can be written as summation, then you write nth term. Then 1 plus x whole power minus 2. Here the sign changes alternatively. So the nth term will be minus 1 whole power n, then n plus 1 into x power n. And the whole series can be written in summation form. So summation, then you write nth term. Okay. So this formula also you should know for solving the problems. So now we'll do problems. We'll start doing problems. So first problem, find the Taylor's expansion of 1 by z about the point z equal to 1. So you write the formula once. Taylor's expansion of f of z about z equal to z naught is, what is the formula? You write summation form, that is n equal to 0 to infinity fn of z naught by n factorial into z minus z naught whole power n. This is a Taylor series formula. Now given that f of z is 1 by z, you have to assume that the given function has f of z. So let f of z equal to 1 by z. About the point given, about the point z equal to 1 means z not equal to 1. Okay. Now you have to calculate the nth derivative here. So to find the Taylor's expansion, it is enough if you find the nth derivative. If you find nth derivative, the problem is completed. This you know that already I given the formulas. What is nth derivative of 1 by x? You see the second formula. If y equal to 1 by ax plus b, then nth derivative is minus 1 whole power n yn equal to minus 1 whole power n into n factorial into a power n by ax plus b whole power n plus 1. So this is the nth derivative of 1 by ax plus b. The same form here, 1 by z. Here a is 1, b is 0. Okay. So what is nth derivative? Nth derivative is denoted as fn of z minus 1 whole power n into n factorial into a power n. What is a here? Coefficient of z. Coefficient of z is what? 1 by z power n plus 1. Minus 1 power 1 is what? Minus 1 power 1. Sorry, this 1 power n is what? 1. No need to write that. Now we want to find out fn of z naught. So what is fn of z naught? That is fn of, what is z naught for this problem? 1. Okay, in place of z you write 1. In place of z you write 1. If you write 1, minus 1 whole power n into n factorial by 1 power n plus 1. And 1 power n thing is 1. Therefore, substitute in Taylor series. If you want, you can keep this as equation number 1. So for 1 becomes f of z equal to summation n equal to 0 to infinity. Fn of z naught is minus 1 whole power n into n factorial by n factorial into z minus z naught is 1 here whole power n. So this n factorial get cancelled. Minus 1 whole power n factorial get cancelled, z minus 1 whole power n. That's all. Finally, write that range. Here the function is z minus 1. So the range is modulus z minus 1 less than 1. You have to write like this. Okay. The region is what? We are getting the series in terms of z minus 1. So how to write the binomial series? Mod z minus 1 less than 1. The region is mod z minus 1 less than 1 for this series. I already told you in binomial series we have 1 minus x whole power minus 1, 1 plus x whole power minus 1, etc. Okay, the series will be in terms of x. Like this. When you have to write this formula, if mod x less than 1, then you have to write this. Similarly for this series, here in place of x we have z minus 1. So the region is mod z minus 1 less than 1. So this completes the first problem. The remaining problem we can see it in the next video.